Hello and welcome back to JD Science Prep. Today we are going to be discussing two-step mole conversions. So what we have here, it says we can use the mole roadmap to do two-step mole conversions for the same substance. So if you have watched some of my previous videos, we've talked about the mole roadmap, how you can go from, let's say, number of particles of one substance to moles of that same substance, and mass of a substance to moles of that same substance as well. We are going to be using that today, except we're going to be taking a look at two-step mole conversions. So the tools that we're going to be using today, again, that moles roadmap. And if you have taken a look at my molar mass video, you will also know we need the periodic table. So let's take a look at the first example here. It reads, what is the volume of 5.06 grams of H2 gas? So let's take a look at what the question gives us here. We are given 5.06 grams of H2 gas, and the question wants us to find the volume of that mass of gas. So if we take a quick look at our moles roadmap here, we are starting at mass, and the question wants us to get to volume. Okay, so you'll notice that there is no direct route from mass to volume. We will have to make a quick pit stop at moles. So the order that we're going to follow, first off, we're going to go from mass to moles. So we're going to follow that arrow. That means we have to divide by the molar mass. Once we're at moles, we can get to volume by multiplying by that constant of 22.4 liters per mole for volume of a gas. So remember, this is only for a gas. Okay. So the first thing you'll recognize, we do need molar mass here of our substance. So let's take a look at that and complete that step first. So we have hydrogen, and H2 means that we have two of them. And let's find the molar mass of hydrogen on our periodic table here. If we zoom in, we have hydrogen right there. We're going to keep two decimal places. So the molar mass of hydrogen is 1.01 grams per mole. Okay. So we're going to write down that 1.01. And since it's H2, there are two hydrogen atoms bonded together. So we need to multiply that by 2, which should get us 2.02 grams per mole for H2. Okay. All right, so we have our molar mass figured out here. I'm just going to zoom out a little bit so we can take a look at that mole map. So we're going to take our given mass, which is 5.06 grams of H2, little time sign line here. And since we're dividing by our molar mass to get to moles, we are going to put that on the bottom. So 2.02 grams of H2, and on the top, it's 1 mole of H2. And another time sign line. So right now, if we were to stop after our first step, we would be at moles. But since we want to get to volume here, we have to multiply by 22.4 liters. So 22.4 liters of H2 gas. And that is for every 1 mole of H2 gas. Okay. And before we calculate our answer, just notice our units do cross off here. Okay. So moles of H2 crosses off, and grams of H2 also crosses off, which means we are left with liters of H2, which is what the question wants us to figure out. So if we type this into our calculator, we have 5.06 divided by 2.02, and that is all multiplied by 22.4, and you should get an answer, I'm just going to write it down here, of 56.1 liters of H2 gas. That should be your final answer. Our significant figures look good. We have 3 in the question. We're going to keep 3 in our answer, and we are happy. Okay, so that is the first example. Let's move on to number 2. It says, or it asks, how many molecules of CO2 are there if there is 24.2 grams of carbon dioxide? So again, let's figure out what we are given here. Looks like we are given the mass of CO2, so 24.2 grams, and it wants us to figure out the number of molecules. So if we take a look at our mole roadmap, we are starting at mass, and the question wants us to find the number of particles. So remember, particles can mean atoms or molecules here. In this case, it means molecules for us. So first off, we're going to go from mass to moles, and from moles, we're going to go to particles. So again, we are working with mass, which means we must figure out the molar mass of our substance here. So we're given CO2. So what makes that up? We have carbon and we have oxygen, and there's only 1 carbon here. There are 2 oxygen. So let's figure out what the molar masses of carbon and oxygen are on our periodic table. So first off, carbon is circled right there. We have 12.01 grams per mole. And oxygen is pretty close nearby. We have 16.00 grams per mole. Let's go write those in. So we have, first off, carbon. We have 12.01 grams per mole. And oxygen, if you can remember, we have 16.00 grams per mole. And just notice here we only have 1 carbon, so this is a simple calculation. We have 12.01 grams per mole, and for oxygen we do have 2, so we must multiply 16.00 grams per mole by 2, so we should get 32.00 grams per mole. So remember, because we're finding the entire molar mass of carbon dioxide, we must add these 2 up. So if we do add them up, you should get an answer of 44.01 grams per mole. That right here is going to be our molar mass of CO2. Okay, so let's begin our question now. Let's write down exactly what we have. We are given, and we're starting with the mass of carbon dioxide. So we have 24.2 grams of CO2. We'll do a time sign line. And if we take a quick look at our moles roadmap here, in order to get from mass to moles, we must divide by our molar mass, which we found. So it's 44.01 grams of carbon dioxide, so CO2, and that is for every 1 mole of CO2. Okay, so if we were to stop there, we would be at moles of CO2, but we must take it one step further, get to particles. So to get from moles to particles, we have to multiply by Avogadro's number. If you're not familiar with that, take a look at my past video talking about the relationship between a mole and 6.022 times 10 to the 23. So we have to multiply by that. So we have 6.022 times 10 to the 23, and that is molecules of CO2. And on the bottom, for every 6.022 times 10 to the 23 molecules of CO2, we have 1 mole of CO2. I'll just extend that line a little bit. And I think we are ready to calculate. Let's check and see if our units cross off. So moles of CO2, grams of CO2, grams of CO2 all cross off, and we should be left with molecules of CO2. So let's type that in quickly here. We have 24.2, and that is divided by 44.01, and that is all multiplied by 6.022 times 10 to the 23. And your final answer, I'm going to write it down here, should be 3.31 times 10 to the 23 molecules of CO2. Okay, so 3.31 times 10 to the 23 molecules of CO2. I'll just make that decimal a little bit bigger here. Perfect. All right. And our significant figures do look good. Our question gave us 3. Our answer, just the 3.31 count as sig figs. This 10 to the 23 does not count whatsoever, so we are looking good. Okay, our last example here, we have what mass of nitrogen gas would there be if we had 8.24 times 10 to the 24 molecules of N2? What about the volume? Okay, so we are given a double question here. So first off, we are given the number of particles, and we are also asked to find the mass as well as the volume. Okay, so let's figure out the mass first. Let's get the brunt of the work done first. So you will remember, if we are asked to find mass, or if we're asked to work with mass, we have to find the molar mass. So we have nitrogen, and we already know that if nitrogen is completely alone, it's going to be N2. Okay, so we have to find nitrogen on our periodic table here. Let's zoom out a little bit, scroll up. And if we find nitrogen, it's right there. So we have 14.01 grams per mole for nitrogen. So let's zoom back to our question here. So we have 14.01 grams per mole. And if we multiply 14.01 grams per mole, we should get 28.02 grams per mole. And that's the only element that we're working with here. So that was pretty simple. Now let's figure out the mass if we are starting at particles. So if we're at particles, we first want to get to moles. So we have to divide by 6.022 times 10 to the 23. And once we're at moles, we must get to mass. So we are going to multiply by the molar mass, which we just found. So let's begin. We have 8.24 times 10 to the 24th molecules of N2. We'll get a time sign line in there. And we must divide by 6.022 times 10 to the 23. So that's going to go on the bottom. So 6.022 times 10 to the 23rd molecules of N2. And I'm just going to move our roadmap over just a tad. We're running out of space here with all these large numbers. There we go, that's a little bit better. Okay, and on the top here, we are just going to have 1 mole of N2. And I'll extend the line just a little bit. And we are at moles right now. We have to get to mass. So we're going to multiply by that molar mass that we found. So we found that it's 28.02 grams of N2, and that is for every 1 mole of N2. Okay, so if we stop there, we are at our final destination here for mass. So I'll write the answer down here. Let's just type it into our calculator quick. So we have 8.24 times 10 to the 24th, and that is divided by Avogadro's number, so 6.022 times 10 to the 23rd, and that is multiplied by the molar mass of N2, so 28.02, and you should get a mass of 383 grams of N2. Okay, our sig figs, we should keep 3 in our question. We're given 3, so let's keep 3 in our answer. And finally, let's figure out the volume here. So a couple things. We can either use what was given in the question. We can either use the amount of molecules, or we can use the mass, which we just found. It doesn't matter that much. But I'm going to keep it simple. Let's use exactly what we were given in the question here. So we were given 8.24 times 10 to the 24th molecules of N2. We're going to get to moles here. So we want 1 mole of N2 on top, and we want Avogadro's number on the bottom because we're getting rid of molecules. So 6.022 times 10 to the 23 molecules of N2. I'll extend that line a little bit. And remember that constant, if we are working with a gas here, folks, and we are getting from moles to volume, we must multiply by that 22.4 liters per mole. Okay, so we have times sign line, 22.4 liters of N2, and that is divided by our 1 mole of N2. So before we calculate, our units should cross off. So moles of N2, moles of N2, molecules of N2, molecules of N2, and we are left with liters of N2. Let's see what we get when we calculate here. So we have 8.24 times 10 to the 24th divided by 6.022 times 10 to the 23rd, and that is multiplied by 22.4 liters of N2, and you should get 307 liters of N2 gas. And again, our sig figs, they do look correct here. We have 3 in our answer, and all the way back in our question here, 8.24 times 10 to the 24, we have 3. So I am happy with that. I hope this video has helped. If it has, give me a like and subscribe.